next problem, we have to find the dimensions of the largest rectangle that can be inscribed in a circle of a radius of 4. So if this is a circle, this will be the rectangle inscribed in it. And now this is the diameter of the circle. So if it's a radius of 4, this will be 8. So now this is, we could just call that x and that y. So x squared plus y squared equals 64. And we know this based on the Pythagorean theorem. We know it's going to be a right triangle. And so you can solve for y, and you get y equals rad 64 minus x squared. So now we're trying to maximize area. So area equals xy. So your area equals x times rad 64 minus x squared. So your derivative is x times 1/2 64 minus x squared to the negative 1/2 times negative 2x plus 64 minus x squared to the 1/2. So then you're going to take the derivative and you're going to set it equal to 0. So 0 equals, we can combine this negative 2x and the 1/2 and the x, negative x out here, now the positive x out here, and make it negative x squared times 64 minus x squared to the negative 1/2 plus the 64 minus x squared to the 1/2. And now if you just add this over, you have x squared over, move this to the bottom, 64 minus x squared to the negative 1/2 equals 64 minus x squared to the 1/2. This is going to turn from negative to positive. So now if you cross multiply, you get x squared equals 64 minus x squared. So 2x squared equals 64, x squared equals 32. So x equals rad 32, and that simplifies to be, you could take out a 16 and you're left with a 2, so that's 4 rad 2. So now if you plug into the beginning, you would have your y is going to equal rad 64 minus, this will be your x, so 4 rad 2 squared. So 4 squared is 16 times rad squared is 2, so that's 64 minus 32, so that's rad 32 as well. So the dimension of the large rectangle will be 4 rad 2, comma 4 rad 2.